Okay, so we're going to talk about the third type of conic section, hyperbolas, today. Hyperbola equations are extremely similar to ellipse equations in how we find everything as well as our actual equation. So for horizontal, x minus h squared over a squared minus y minus k squared over b squared equals 1. Or vertical, same thing, just switching the denominators. If you'll notice two things about hyperbolas. The first is that it's a minus. With ellipses, your equation is a plus, but a hyperbola has a minus equation. Secondly, it equals 1, just like an ellipse equation. It always has to equal 1. Here's a trick with hyperbolas, which is a little annoying, is that a is not the biggest number with hyperbolas necessarily in your denominator. It can be or it cannot be. So in order to tell if a hyperbola is horizontal or is vertical, we look at which variable comes first. Here, x comes first, or x is positive, so it's horizontal. Here, y is first, or y is positive, so it's vertical. You're going to find your vertices, your co-vertices, and your foci the exact same way as you found with hyperbola. The other thing that's different with hyperbolas is we have asymptotes. So for the horizontal hyperbola, asymptotes are going to be y equals k plus or minus b over a times x minus h. And for vertical, it's going to be y equals k plus or minus a over b times x minus h. So the only difference is horizontal is b over a, vertical is a over b. For your foci equation, that's a little different as well. It's c squared equals a squared plus b squared. In the ellipse equation, it was minus, but for hyperbolas, your c is plus. I like to think about it as whatever your actual equation sign is the opposite of the c equation sign. So because hyperbolas are minus, the c equation will be plus. With ellipses, we had a plus equation, so our c equation was minus. If I scroll down a little bit more, we can see between horizontal and vertical, your center is hk, just like usual. Your vertices, h plus or minus a, or h k plus or minus a. Your co-vertices, h k plus or minus b, or h plus or minus b, comma k. Your foci, we're adding c to the x part if it's horizontal, to the y part if it's vertical, and you get your asymptote equations. So there are two ways you can graph asymptotes. First is box method. This is what I like to do personally. I'm going to show you it first. So I need to find all the stuff. So I can say here that my center is 1, negative 2. For box method, you need to find all 4 vertices. So that would be v sub x is 1 plus or minus 2, comma, negative 2. Since the square root of 4, x's denominator is 2, we add that and subtract that to the x. Your v sub y is 1, comma, negative 2 plus or minus 1. Since y's denominator 1, the square root of that is 1, we're adding and subtracting it to the y part. We're going to need to get our foci. Because your x is first, this is going to be a horizontal equation. Or a horizontal hyperbola, excuse me. So we're going to add and subtract c to our x part. We have to find c. And c squared equals a squared plus b squared, which is 4 plus 1. So c squared equals 5, and then c will equal square root 5 when we solve for c by square rooting. I'm going to add that in. We also need to write our equation for our asymptotes. The asymptote equation for horizontal is y equals k plus or minus b over a times x minus h. And in this case, y is going to equal k plus or minus, b is 1, a is 2, looking at the square roots of the denominators, x minus 1. And these are everything you need to find your graph. Now I can go ahead and graph. I'm going to graph the center and all of my vertices. So center is 1, negative 2. My x vertices, 3, negative 2, negative 1, negative 2. My y vertices, 1, negative 1, 1, negative 3. Now we're going to make a box through all 4 vertices where your vertices are the center points of each side. So I'm going to start here on the left. It's a magical invisible box as well. So it's not really part of the graph. So we have dashed lines. I'm going to go all the way up to my next point, all the way across to my next point, all the way down, back across, and all the way up. That's your box. Then you're going to make lines, diagonal lines that go through the corners of the box, through the center. So through the center, through the corners, and both sides are going to make 2 diagonal lines. And these are our asymptotes. So instead of graphing your asymptotes from the equation, we can make a box. You only need the vertices from whatever type of hyperbola this is. So this is a horizontal hyperbola, so we only need the x vertices. From the x vertices, we're going to approach both of the asymptotes without ever touching them. So we're getting closer and closer to them without touching. And lastly, we need our foci. We can throw that in. Make sure you label your foci and your center. And here is our hyperbola. Your graphs are bending around your foci. They're approaching but never touching your asymptotes. You have 2 asymptotes, and they're back to back. So this is the first way. And then I'm going to show you how to find how to graph it using the asymptotes. Okay, so if we're going to graph the same exact problem using the asymptotes, we need to find the center, which was 1, negative 2. You don't need to find all the vertices, only the x vertices because it's a horizontal hyperbola. If it were a vertical hyperbola, you would only need to find the vertical or the y vertices. So I'm only going to find v sub x because it's horizontal, because x is first. And that's 1, comma, oh, just kidding. That's 1 plus or minus 2, comma, negative 2. You're going to need to find your foci. Because it's horizontal, we're adding and subtracting to our x part. To find that, we would say c squared equals a squared plus b squared, which is 4 plus 1, which gives us 5. And then we square root, and we get c equals root 5. I'm going to erase this work now because I'm going to need the space. So the last thing you have to do are the asymptotes. Y equals k plus or minus b over a times x minus h. The plus and minus give you two answers, one for a plus, one for a minus. So we are going to get two lines. We need to separate them and find out what they are in slope-intercept form. So I'm going to do y equals negative 2 plus 1/2 times x minus 1, and y equals negative 2 minus 1/2 times negative 1. I'm sorry, times x minus 1. So I'm going to distribute the 1/2 here. So y equals negative 2 plus 1/2 x minus 1/2. And then the negative 2 and the negative 1/2 are like terms, constants, so I can combine those. Y equals 1/2 x. Negative 2 minus 1/2 is negative 2.5, and I can write that as one improper fraction of negative 5/2. Coming over here, I'm going to have to say y equals negative 2, distributing the negative 1/2, minus 1/2 x plus 1/2. And the negative 2 and the plus 1/2 are like terms, so I can combine those. And negative 2 plus 1/2 is negative 1.5, or as one improper fraction is negative 3/2. So here I have my two asymptote equations in y equals mx plus b form. I can graph those. The first one, your b, or your y-intercept, is negative 2.5. Your slope is positive 1/2. So going up over 2, up 1, over 2. And asymptotes are always dashed because they're not really part of the graph. The second one, negative 3/2, or negative 1.5 is your b, and the slope is negative 1/2. So I'm going down 1, over 2, down 1, over 2. And I'm going to make my line. You'll notice the intersection of the graphs of these two lines, these asymptotes, is the center of your conic, of your hyperbola, 1, negative 2. From there, you can graph your vertices. So that would give you 3, negative 2, and negative 1, negative 2. From your vertice, you're going to approach the asymptotes on both sides, getting closer to them, but never touching them. And lastly, throw in your foci, the part that your graph bends around, labeling your foci and your center. And there you have it. It's the same exact graph as if you did box method, or you could do this method. I will leave it up to you to decide which one you feel more comfortable doing, and you do that. Okay, so now I want you to go ahead and try to do B. Pause the video and fix it. Actually, this is the end of the first video, so you can watch a second video to continue on and get your answer.